Hello students, today I am going to explain JEE main session 1 Jan 2024 from chemical bonding and molecular structures. First question 27th Jan shift 1, choose the polar molecule from the following: CH2 double bond CH2, CCl4, CHCl3, CO2. If you take CH2 double bond CH2 and CCl4 CHCl3 CO2. Observe the dipole moment direction in this and here towards the chlorine, more electronegative atom chlorine, and here towards the carbon in CH bond, in CCl bond towards the chlorine vector quantity CO2. So dipole moment here 0. Why? Because directions are opposite in direction. Here also 0. Here also 0. But here 2 are in one direction, 2 are in another direction, but the net dipole moment is not equal to 0. That's why it is polar molecule. Third one is correct. Next, sum of bond order. Second question, 27th John shift 1 only. Sum of bond order of CO and NO. How we are going to find bond order? Simple. I'll give bond order formula: number of bonding electrons minus number of anti-bonding electrons divided by 2. Okay, so to find this entire number of bonding electrons and anti-bonding electrons takes lot of time. That's why I'll give simple trick to find bond order. For example, take carbon monoxide, carbon atomic number 6, 6 electrons, oxygen 8, 6 and 8, 14. If 14 electrons are there, bond order 3. Next, NO plus, nitrogen 7, oxygen 8 plus, but plus 1 charge is there, that's why here also 7, 7 plus 7, 14. Bond order NO plus also 3. They ask sum of bond order CO3 and NO plus also 3. So 3 plus 3, 6. That's why sum of bond order of CO and NO plus is 6. Next, third question. The number of non-polar molecules from the following is: HF is a polar molecule, H2O also polar molecule, H2O is a polar molecule, H2 is non-polar molecule. Next, CO2 is non-polar molecule, CH4 is non-polar molecule, and BF3 is non-polar molecule. Total 4 non-polar molecules. HF is polar. Why? Because due to difference in electronegativity of hydrogen and fluorine and vector quantity in only one direction. That's why dipole moment is not equal to 0. It is a polar molecule. Next, you take fourth question. The number of compounds with one lone pair of electrons on central atom amongst following is: O3 has one lone pair electron, H2O has one lone pair electron. SF4 has one lone pair electron. CF3, chlorine is a 17th group element, contains 7 valence electrons. Out of 7, 3 involved in a bond formation with fluorine, remaining 4 electrons. 4 electrons will give 2, right? That's why lone pairs ozone 1, oxygen 1, SF4 1, ClF3 2, NH3 1, BrF3 bromine 17th, 5 involved in a bond formation and remaining 2 forms one lone pair. XeF4 oxygen 18th group, out of 8, 4 electrons involved in a bond formation, remaining 4 will give 2 lone pairs. Now the question is the number of compounds with one lone pair of electrons on central atom. How ozone is 1? Take a structural formula: O double bond O single bond O. Each oxygen has 6 electrons in their valence shell, so 2 involved in a bond formation, remaining 4 non-bonding electrons. Here 3 involved in a bond formation, remaining 3, and here 1 bond, 1 involved, remaining 5. To show the octet electronic configuration, we are taking 1 electron from this oxygen. That's why this oxygen atom contains only 1 electron in the central atom. 1 lone pair of electrons in the central atom. So total number of compounds with 1 lone pair: 1, 2, 3, 4, 5. The answer is 5. And how NH3? Take NH3. Nitrogen 15 group elements contains 5 valence electrons. Out of 5, 3 involved in a bond formation. Remaining 2 are non-bonding. Forms one lone pair. Next, the number of species. Question number 5, 20, 24, 29 John shift 1. The number of species from the following which are paramagnetic and with bond order equal to 1. Observe these species. Bond order H2 is 1 but it is dia. He2 plus. He2 plus. Count the number of electrons. H2, He2 plus, O2 plus, N2 2 minus, O2 2 minus, F2, Ne2 plus and B2. Take total number of electrons. H2 2, He2 plus, helium 2 atomic number. He2 means 4 electrons but plus 1 3, and O2 2 plus, O2 2 plus. Our total electrons 8 in each oxygen. 2 oxygens are there. 16 plus 1 15. Next, N2 2 plus. N2 means 14 electrons. 2 minus means 16 electrons. O2 2 minus. O2 means 16 electrons. 2 minus means 18. F2 means 18 electrons. Ne2 plus. Ne is neon, 10 atomic number. Ne2 means 20 plus 1 means 19. B2 boron 5, 2 means 10 electrons. Now how we can find the bond order is equal to 1 or not? If total number of electrons are 14, bond order 3, 15 2.5, 16 2, 17 1.5, 18 1, 19 0.5, 20 0. Next, less than 14. So less than 14 means 13 2.5, 12 2, 11 1.5, 10 1 and 9 9 0.5, 8 0, 7 0.5, 6 1, 7 1.5, 7 over 5 1, 4 1.5, 3 1, 2 0.5. Sorry. Yeah. Now take He2 bond order 1, but it is dia. Why? Because even. We'll think about He2 plus. O2 plus 15. 15 electrons 2.5. Bond order 2.5. Not equal to 1. Next, N2 2 minus 16. 16 means bond order 2. Even number of electrons, no unpaired electrons. 18. Bond order 1. Even number of electrons. Next, F2 18. Bond order 1. Next, Ne2 plus. Ne2 plus 19 0.5. B2 plus 10. 10 means here 13 0 2.5, 12 to 11 1.5, 10 means 1. But even number of electrons, there is a possibility for diamagnetic. Next, He plus bond order 3. 3 means 1.5. Now how we can find it is paramagnetic or not? The with bond order equal to 1. Now check carefully. Take electronic configuration sigma 1s, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2p, pi 2px, pi 2py, sigma 2pz, pi star 2px, that is equal to pi star 2py, sigma star 2pz. This is when the atomic number is equal or lesser than 7. For nitrogen, we can take from oxygen, and we have electrons more than 2, right? So then we are going to change the electronic configuration. First we'll take this sigma 2pz. Now bond order 1 O2 2 minus F2 and B2 less than 1. Will check with 10. 2 4 6 8 9 10. So B2 will show paramagnetic with bond order 1. Next F2 18 electrons 2 4 6 8 10 10 12 14 16 18. So here also there is no possibility for paramagnetic, diamagnetic only. Next, O2 2 minus 18 also no possibility. Next, N2 2 minus bond order is not equal to 1. Here anyhow it is dia. Why? Because H2 all are in bonding electrons only. N2 2 plus bond order, Ne2 plus 0.5 is the bond order. So the species with the paramagnetic with bond order 1, only one, that is B2. Next question. The total number of molecules with zero dipole moment: CH4 0, BF3 0, CO2 0, 3. H2 is not equal to 0, HF not equal to 0, NH3 not equal to 0, SO2 not equal to 0. Why? Because CH4, BF3 and CO2 are non-polar molecules. That's why dipole moment mu is equal to 0. Total number of sigma and pi bonds are present in 2 formyl. Next question, question number 7. Total number of sigma and pi bonds are present in 2 formyl hex 4-ene oic acid. Take a structural formula. Hex 3, 4, 5, 6. Oic acid at end. Next, 2 formyl, 1, 2. Remaining all are hydrogens. 4-ene, 1, 2, 3, 4. 4-ene means at 4th carbon double bond. 4, 5, 6. Remaining all are hydrogens. Now count number of sigma and pi bonds. First I'll find pi bonds. 1, 2, 3. Pi bonds are 3. Sigma bonds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Sigma bonds are 19. The total number of sigma and pi bonds: sigma is 19, pi bonds 13. Sum of these two, 12. The total number of antibonding molecular orbitals formed from 2s 2p atomic orbitals in diatomic molecule. 2s forms 2 sigma 2s sigma star 2s. 2p forms sigma 2pz pi 2px pi 2py. Sigma star 2pz pi star 2px, that is equal to pi star 2py. So antibonding with star 1, 2, 3, 4. The total number of antibonding molecular orbitals from 2s and 2p is 4. That's why the answer is 4. Next question, question number 9, 2024, 30th Jan, shift 1. So BRF3, bromine is 17 group element, contains 7 electrons. Out of 7, 5 involved in a bond formation and remaining 1 non-bonding. 5 bond pairs, 1 lone pair, total 6. 6 means hexa octahedral, but 1 lone pair with 5 bond pairs, then it is square pyramid. Next, H2O, you know very well, 2 bond pairs, 2 lone pairs, bent shape. Next, ClF3, chlorine is 17 group elements. Out of 7, 3 involved in a bond formation, remaining 4. 4 means 2 lone pairs, 2 lone pairs, 3 bond pairs, total 5. 5 means trigonal bipyramidal. 3 bond pairs, 2 lone pairs, T shape. SF4 sulfur 16 group elements contain 6 valence electrons. Out of 6, 4 involved in a bond formation, remaining 2 non-bonding electrons. Non-bonding electrons means 1 lone pair, 4 plus 1 5. So trigonal bipyramidal with 1 lone pair, the geometry changes to seesaw. Now match this. BRF5 square pyramidal, A4. Next, H2O bent shape, A4 B3. Next, ClF3 T shape, C1. SF4 seesaw, D2. A4 B3 C1 D2. First option is correct. A4 B3 C1 D3. Next one, 10th question. The total number of molecular orbitals formed from 2s 2p atomic orbitals. See here, we discussed anti-bonding molecular orbitals 4, bonding molecular orbitals 4. 1, 2, 3, 4. So 4 bonding, 4 anti-bonding. Total number of molecular orbitals 8. 4 bonding molecular orbitals, 4 anti-bonding molecular orbitals. Total 8 molecular orbitals. Next question. Given below are two statements. Since fluorine is more electronegative than nitrogen, the net dipole moment of NF3 is greater than NH3. Second statement. In NH3, the dipole or the orbital dipole due to lone pair and dipole moment of NH bond are in opposite direction. But in NF3, the orbital dipole due to lone pair and dipole moment of NF bonds are in same direction. In the light of above statements, choose the most appropriate from the option given below. First, take the structural formula of those two. First one is NH3. NH3 with one lone pair. NF3 also same. 3 NF bonds and one lone pair. See students, now take a direction, vector quantity it is. Hydrogen is less electronegative, nitrogen is more electronegative. Vector quantity towards nitrogen. Now, the dipole moment always towards lone pair of electrons. Here, take fluorine and N nitrogen. Fluorine is more electronegative, vector quantity towards fluorine. Here towards lone pair. See, in NH3 all are in same side. Lone pair dipole and NH dipole same side. But here they given opposite. That's why statement 2 is wrong. In NF3 NF direction and lone pair direction is opposite. But here they given same. That's why statement 2 is wrong. Statement 1. Fluorine is more electronegative than nitrogen. The net dipole moment of NF3 is greater than NH3. No. When these two are in opposite direction, will get cancelled. Net dipole moment of NH3 is greater than NF3. Statement 1 is wrong and statement 2 also wrong. That's why both statement 1 and 2 are false. Second one is correct. Next, question number 12. 2024 31st John shift 1. The linear combination of atomic orbitals to form molecular orbitals takes place only when the combination of atomic orbitals have same energy, no, have maximum energy, but here they given minimum overlap, have same symmetry about the molecular axis. C correct. Have different symmetry about the molecular axis. No. So that's why A and C only correct statement about formation of linear combination of atomic orbitals, LCAO. Next question. The number of species from the following in which the central atom uses sp3 hybrid orbitals in its bonding is. Options are given: NH3, SO2, SiO2, BeCl2, CO2, H2O, CH4, BF3. Out of this, NH3 hybridization sp3, SO2 NH3 hybridization sp3, SO2 sulfur 16th group element contains 6 valence electrons. Out of 6, 4 involved in a bond formation with 2 oxygen, remaining 2 electrons, 1 lone pair. So that's why sp2 hybridization. SiO2 silicon dioxide sp hybridization like CO2. BeCl2 sp hybridization. CO2 sp hybridization. H2O sp3 hybridization bent shape. CH4 sp3 hybridization. BF3 sp2 hybridization. Now NH3 is 1. Next H2O, CH4 also sp3, BF3 is not. So total 3 are. One is NH3, H2O and CH4. Total 3 will form sp3 hybrid orbitals. Which of the following is least ionic? Next question number 14. They asked in 2024 session 1 31st John shift 2. Which of the following is least ionic? So B, barium chloride and potassium chloride, S block. Cobalt and silver, D block. So D block ionic are least ionic. Out of cobalt and Ag forms least ionic. Next question. Question number 15. A diatomic molecule has dipole moment of 1.2 dB if the bond distance is 1 angstrom. The fractional charge on each atom is given 1 dB is 10 to the power of minus 20. So now dipole moment mu is equal to q into distance. Q they given 1.2 dB, but in ESMU 1.2 into 10 to the power of minus 8. Distance we are going to find d. Fractional charge, first find distance, then we can get fractional charge. Mu value they given, that is 1.2 into 10 to the power of minus 18 is equal to q is the question mark. Distance 1 angstrom, convert into centimeter, 10 to the power of minus 8. Now q is equal to 1.2 into 10 to the power of minus 10. Convert this into ESU. Then this is already in ESU. Now fraction of electron charge. Fractional charge, that is q by dipole moment. So that is q, how much we got? 1.2 into 10 to the power of minus 10 divided by 4.8 into 10 to the power of minus 10, that is 0.25 or 2.5 into 10 to the power of minus 1. That's a fractional charge, 2.5 into 10 to the power of minus 1 or 0.25. Why we are taking 4.1? Diatomic molecule plus 1 and minus 1, that's why we will take this. Next, 16th question. Arrange the bonds in order of increasing ionic character in molecule like LiF, KO2O, N2, SO2, ClF3. No doubt ionic character is least in N2. Why? Because it is a non-polar molecule. Maybe option 1 or 2, not 3 and 4. Next, take this to SO2 and LiF is highest. SO2 and ClF3. Out of these two, ClF3 is more ionic than SO2. So that's why option A, option first one is correct, second one, third, fourth one is wrong. N2 is least ionic, then SO2, then ClF3, then K2O, then LiF. Next, 17th question. Given below are two statements. One is labeled as assertion and other is labeled as reason. Assertion: pH3 has lower boiling point than NH3. Reason: in liquid state, NH3 molecules are associated through van der Waals force, but pH3 molecules are associated through hydrogen. So assertion is correct, but reason is wrong. Why? Because when pH3 has lower boiling point than NH3, at that time NH3 should contains hydrogen bond. That's why option 1 is correct. A is correct, but R is not correct. Question number 18, 2024, first, fifth, shift 1. The number of molecules or ions having trigonal bipyramidal shape. For trigonal bipyramidal shape, bond pair 5, lone pair 0. Then hybridization sp3d. So bond in P of 3, bond pairs 5, lone pairs 0. In BRF5 and PCL5, BRF bond pairs 5, lone pairs 1. PCL5 bond pairs 5, lone pairs 0. Next you take BF3 FeCO taken 5 times. Bond pairs here 3, lone pairs 0. Bond pairs 5, lone pairs 0. So to satisfy the trigonal bipyramidal, bond pairs 5, lone pairs 0. That is possible in PCL5, PF5 and FeCO taken 5 times. That's why answer 3. Next, question number 19. First, fifth, shift 2. Given below are two statements. Statement 1. A pi bonding molecular orbitals has lower electron density above and below internuclear axis. Statement 2. Pi star anti-bonding molecular orbitals has nodes between the nuclei. Statement 2 is wrong. Statement 1 is correct. Statement 1 is false, but statement 2 is true. Second one is correct. Select the compound from the following that will show intramolecular hydrogen bond. Intra means hydrogen bond formed within a molecule. So this is orthonitrophenol. Take a structural formula of orthonitrophenol. OHNO2. Between these two will get hydrogen bond. That's why it is intramolecular hydrogen bond. C2H5 does not form, H2 also does not form. NH3 also does not form. So second one, orthonitrophenol, forms intra. Yeah, that's it. I hope you understood this explanation. If you understood, please subscribe my channel and like the button. Click the bell button and share with your friends. Thank you.